Hey Malta, this is Steve, and I thought I'd walk through how I approach this stuff just because it might help. First off, let's make sure we're where we all want to be. So that's clearly not where we want to be. How about Git pipe core? Okay, so I've created another branch off of hierarchical nets called timed transitions, and I sent the commands for that, but we should be at the beginning of timed transitions. The commands I sent are slightly different than the ones I executed to get this set up, so I'm not sure it'll exactly work, but this is where you're going to want to be. If we do git remote, something like that, your origin would be Malta shilling right here, and then your upstream should be same thing, Sarah Tattersall's repository. And then if we do something like git branch all, maybe, it'll show you that there's a origin is your fork of Sarah's upstream. So I'm pushing, we're all going to push to this upstream, to Sarah's repository. Sorry, we're going to push to our own version. I'll push to my remote, which is sjday, and you'll push to Malta shilling pipecore.git, and then we'll both issue pull requests from our fork here to the real upstream, which is Sarah's, and that's what we'll all share from. Hope that makes some sense. Let's walk through it here. Okay, let's go do some Eclipse. So if we look at discrete, so in thinking more about a place to start, well, we talked about running a whole petrinet, and that's a petrinet runner test. And then we said, well, maybe that's not detailed enough. Maybe we need to figure out what happens when a particular transition runs. And so we said, well, let's go in the animation logic test. Well, and then we looked at how a discrete transition works, and it has this fire method. And we said, well, there's nothing there for timing, so maybe we should figure out how to do the timing in that method. And we talked about whether we might put that in a separate class. So so let's noodle with that. It might not be the best thing, but we could start with that. And so when I think about that, I say, well, okay, before I get to the running it in a full-scale animation, maybe I should just verify that I can create a timed transition and do something with it. So then I say, well, okay, what do we have for transitions to begin with? We have the discrete transition test, and this guy does, well, actually, if we do this, we can see over here in the outline that it does wrong. That's not where I want to be. I want to be here. Discrete. Well, that wasn't what I wanted to do either. Discrete transition test has a bunch of things. Calculates. If we make this, I wonder if we can make this bigger. Can we just do that? We can't. Okay. Well, it has a bunch of calculates arc connections and blah blah blah, and visiting stuff, and there's an evaluate rate and an actual rate, so a bunch of things in that test. So that's what we have for discrete transitions right now. But what we want to do, I think, is maybe we want a discrete time to transition. So let's create one. So Alt Command N gives me, so far, nothing. Let's do this. Let's try this. If I do this, I get a JUnit test case. Let's create one of those. I want to put it in the source test tree, so that's the right place. And it's going to go in this same package, the models petrinet, where the other one is. And so maybe instead of a discrete transition, I don't know, discrete time to transition. Is that what we're going to call this? Why not? Okay. So that creates a kind of simple-minded test here. Let's just get rid of that. And I don't know. Whoops. How about create timed transition? Sort of a basic starting thing. Well, we know we want it to be a transition, so let's call it that. But we're going to create a new class here, and the kind of test-driven game is I write a line of test code and then I write just enough to get my test to pass. So we want to create a new thing, maybe a discrete timed transition. And if we look at what a discrete transition looks like, well, it's got a few. First off, it extends an abstract transition, so presumably we're going to end up doing something there. It's got a few different constructors. One is where you can give it an ID and a name. One is where you just give it an ID and it sets the ID and name to be the same thing, and then you can also give it, you know, a rate and a priority, blah 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 blah. Well, let's start with something simple. So sounds like we're going to want to. We'll give it just an ID. Start with something like that. Okay, so he doesn't know what to do with that because obviously this class doesn't exist yet. So we pull up our helper. We say create class discrete time transition. Now we're in a test and we want to create it where the rest of where the real production class code is, which is in the main stream there. But other than that, it's going to be the same package, and it implements this because we started out by defining it as a transition. We know it's going to implement this transition interface. So we might want to change that. So notice that it says public class discrete time transition implements transition. All right, well, so far so good, I suppose. Let's save this. It should at least compile now. Oh, now if I say what's the problem, if I do command 1, it says, well, it's got an argument that I don't recognize, or you could create a constructor that took a string. So all right, let's do that. So it goes in. It's going to create a constructor. We might call this ID, since that was kind of our idea. Okay, so now it compiles. So I guess there are some things about this. Maybe right off the bat, more than at a minimum. We ought to be able to assert that this transition is timed, right? So let's think about that for a minute. So if we go back to the transition, if we go to the transition interface, well, okay, it's got a bunch of messages that it's used in various times. We can get a priority, get and set a priority. We can get a rate, set a rate, a bunch of stuff with rates. Ask whether it's an infinite server, something about angles, and then this is time, set timed thing, and enable and disable. and then down at the bottom, fire. So fire is what we really are going to want to implement down the road, but there are some things right out of the gate that we know we had better set. So we're expecting this to say, yes, it's a timed transition. So yeah, why don't we just say that and see whether our tests run. One thing I forgot to do that I should just do right now is here. I'm going to comment this baby out. And before I do anything else, before I ruin anything, I should have run all the tests. Run, blah, 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 run history. Maybe do run history. Run history, all pipe core tests. I have a run configuration to set up to run all my pipe core tests. Let's see whether it does. Just thinking about it. This ought to be 5 seconds of our life that we never get back, but that's all it really should be. Maybe 8 seconds. Come on, machine, you can do it. The first time is always a little slower. I'll only begrudge it some of that time. All right, 15 seconds, appalling. So what happens if I do that again? I think part of the problem is that something is eating up cycles on my machine. So in my book, a good 8 seconds, right? A good elapsed time is about 100 tests a second. So that's a little slow, but we're running 500 tests in 8 seconds. All right, now, it could be worse, but okay. Well, my machine is a little slow, probably because of this recording. Let me get out of this. Okay, so we got all of our tests running. So let's run our new test. And I guess I'd be pretty surprised if this ran right, because it should default to false here. So let's run it as a JUnit test. And he says, nope, it's not a time transition. So, okay, so we've kind of, we started out by just getting something to compile, and then we wrote a test. We haven't added any behavior to speak of here. So far, we don't even know, we can't even say anything about the ID because we haven't done anything with it. And I think that a first error here is that we're implementing transition, but what we probably really want to do is do something like extends discrete transition. Something like that, I would think. And he says, well, what the heck is a discrete transition? Ha! 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 Okay, well, so if we go to discrete transition, we notice that it's final. So there's a philosophical point here, I guess, which is whether we want people to be able to go ahead and extend our stuff. And I have a fairly permissive attitude towards that. I'm not a big believer in final, because it's that supposes I actually have the final word on things, and I usually find that I don't. So I'm going to take that off, and we're going to see what happens next. All right. So he says that's okay. Now he's going to say, all right. So now all these things that we pulled out from the interface, I don't think we want to do those anymore. I think we're going to let that be the problem of our superclass. So let's get rid of all this stuff, and we'll add in what we need to later. So, okay, so error number one was we implemented the interface rather than extending the superclass. Okay, so this guy is probably going to tell me that I really ought to implement something that I'm going to have to call super. So, well, I don't believe any of that. So how about this? Super ID. Maybe that'll work. Better. Got some extra imports there I didn't need. All right, so we've got super ID. So we're at least calling that guy. And let's run this again. Still fails. So when we go to discrete transition, and we say all this stuff, well, I'm going to suggest that if we are a discrete timed transition, that at the time we're created, we already know something about ourselves. Sorry. We know that not only do we know our name, but we know that ID timed, I think it's set timed. Set timed, yes. Set timed true. You know, we just are a timed transition just by the fact of being created. All right, so let's see whether our test runs. Bingo. Okay, life is good. All right, so we know that. I guess we probably ought to be able to assert a few other things. Equals T0 transition dot get ID. I ought to be able to assert that, and that actually might just work. Probably should have written that test before actually calling super. I like to see the test fail before I make it run. All right, so we've created time transition, and I guess so. Maybe the only other thing we want to test so far is what happens when we fire this sucker. So why don't we do this? Now this is a macro on my system. Probably doesn't exist on yours, but so why don't we say something like delay can be set. All right. Well, so I think we probably want to do something like transition dot, I don't know, set delay 1.0, something like that. Okay, so first thing is he doesn't recognize this variable. So rather than create it all over again, let's do this. Highlight it. Refactor it to a local variable to field, and then be extra fussy. This is also something that's on my on my Eclipse, just a macro to create the before method. So it seems like every time I do anything with a transition, I'm going to do that. create one. So now I can, now I know I've already got a transition, but I want to set its delay. And of course that method doesn't exist. So we're going to create it. And where are we? Well, we're in the transition interface. And so this all probably looks okay. Public void set delay. And let's well, okay. Let's be good citizens here. All right. For this, let's see. How do we do this? At link something like discrete timed transition, or maybe it should be C. Specify so well so we could specify this in seconds, or maybe we should specify it in milliseconds. I don't know, an awful lot of things get specified in milliseconds. Specify the amount of time in milliseconds, where we spell milliseconds correctly, that this transition will wait once it's enabled before firing. How about that? And that's going to mean that this should be really an int. I don't know, how about delay milliseconds? Delay, all right. So, okay, so that's going to kind of break our original code here, because now we want this to be something like 1,000. Now, so I guess probably the first thing we want to ask ourselves is assert equals 1,000 transition.getDelay. Now, all right, so need to create that method, and in this case it's public int, and the delay in milliseconds, that this transition will wait once enabled before firing. Okay. Let's see. Note that this is not deterministic. All that is all is guaranteed is that delay milliseconds will elapse is that a minimum of delay milliseconds will elapse. There is no fixed upper limit on the amount of time elapsed time before firing. All right, that's really not very clear, but the idea here is that if a lot of things on the queue could take a long time, and if we were running a virtual machine, it could be days. we could have gotten suspended. Okay, all right. So get delay. So that's that. Now, a couple things that are almost certainly going to be the case here. One is that we can't run this yet because, yeah, errors exist. All right, cancel. Why? Because a bunch of things aren't compiling. So this guy for sure needs to implement some things. So this is our, oh, it's a discrete external transition. Oh yeah, okay. So, all right, let's go look at the other one. Let's go to discrete transition. So, first off, why aren't we fixing this in our class? Well, the reason we're not fixing it in our class is we just extend this baby, and so this baby is the one who implements, oops, make this bigger. He's the guy who implements transition, so he's the guy who's got to abide by that contract. So that's his problem. So let's see what he says. Add unimplemented methods. Let's go down here to the bottom, and so there they are, so that's that, and we're gonna have to do the same thing. Let's go look at our problems again for this guy, and we'll let him. That's command 1 gets us all the errors, and so we'll let him default to that. Now, okay, so that's a little bit stupid because we just did this twice in two different classes, and we don't actually plan to use it except in the subclass. So is there any reason why we couldn't stick it up here in abstract transition? And it does a few things, does a bunch of things actually, but it has basic getters and setters. So I'm thinking that let's go back to discrete external transition, and let's not put it there. Let's go to discrete transition, and let's take these guys, highlight them, then Alt Command T, oops, not that one, Alt Command T, pull up. Now, okay, so that didn't work right. Let's Control Z this bugger, try that again, pull up. Oh, didn't take my highlighting, but set delay and get delay. We're going to pull them up, and we're going to put them. Our destination, though, isn't going to be transition. This is impossible to read, but I'm going to pull the drop down and find abstract transition here, and set delay and get delay. We're going to pull up, and we're going to go next. We're going to see whether we got errors. Looks okay. Go next. It's going to figure out what's going on. Going to tell me what it's going to do there, and I'm going to say finish. Okay. All right. So now, discrete transition. Okay. So ignoring that stupid problem, which is not relevant. Both discrete transition and discrete external transition both extend abstract transition, and that guy has got our logic in it. So now let's run our test again, which I'm going to expect fails. Delay can be set. Can't be. We expected 1,000, but it was 100. Now, if we think about that, see, where we put that was in abstract transition. If we actually go to abstract transition, we find that, son of a gun, well, we set the delay. We don't actually do anything. So probably be good if we did something. All right, so how about this? This dot delay equals delay. And let's return delay here. Alright, so he doesn't know what delay is yet, but pretty sure we can create a field for that. And everybody's going to be able to process that if we go up top. Alright, so let's explain what it is we just added to this baby. Here we go. So delay in milliseconds before transition will fire once enabled. All right, now okay, so with that, maybe our little test will run. Okay, so far so good. Let's try one more thing. Oh, well, I'm not sure why I did this, but let's rename this. Refactor, rename, and let's get rid of the extra test because, you know, no point in being that redundant. All right, so we renamed him. Now, well, we verified the delay. Actually, you know, it might be nice to know that the default delay is 0. Default. Okay, well, that wasn't really what I wanted to do. Let's try this default. All right, that still runs. Okay, now I guess the real test is something like verify how it waits delay milliseconds before firing. Okay, so we've said that we'd like to set a delay on this thing. And I guess after that, we'd like to do something like transition.fire, right? we want to say something like, you know, current time assert current time is at least 1,000 milliseconds later. All right, well, and then, but as I mentioned before, it's kind of nice. It's kind of nice when you don't actually have to wait a second, because after all, we want 100 tests to run in a second. So let's not actually wait that long. Let's pretend like we're gonna wait that long. So I don't know, if we futz around here, system dot current time in millis. Well, so that's what we're going to play around with in the real code, but we don't actually want to play with the system clock here. I guess what we'd like to do is say something like well, so a couple things. Kind of a general pattern here is that we there are some things that we set just for testing. So set time, set current time for testing, and that sounds fairly horrible. It's kind of crummy to think about having a method that's clearly a testing method right in your production code. But although that's not wonderful in OO terms, I sort of excuse it by giving it a label that says, this is just for testing, don't use this in production. And it makes the testing game a lot simpler, particularly when you're talking about something that is that's dependent on something kind of tough to get at, like the system clock. So let's bear with me on this, and I don't know, let's just say it's 40,000, just for laughs, and then we say, okay, it's 40,000 milliseconds, and so a couple things about this. One is, if we look at what he wants to do here, he wants to put it in type transition, and so I do have a little bit of heartburn about putting a testing method right in a public interface if I can help it. So sort of compound the sins here by doing something like this. How about if we cast this thing to a discrete timed transition like that, and then we say, okay, it means we're going to hide this method just there, and do that, something like that, and then he says, now we're going to you're suggesting we create this baby in discrete time transition. I'm saying, yeah, let's hide it there. And maybe let's make it protected so that it's not as obvious that it's there. All right. So we'll call this, I don't know, call it current time. So, okay, good enough. Let's go back. And, okay, so we've set our current time for testing at 4,000. And so I think what we're, so let's talk this through for a second. I think the notion is that so let's do it this way, and then probably rework it. So set current time for testing. Then we fire, and so the question is, who's gonna do the waiting? How's that really gonna work? And you know what? Let's see. What's the simplest thing we can do here? Well, okay, so I'm going to do the wrong thing. I'm just going to wait, and then we'll check, let's see here. How's it gonna? What are we gonna do? What we want to say here is, why don't we do this? We'll call this an int fake time equals this number x, and we'll do this, and then transition fire, and then we'd like to assert something like well, 41000, right, is well, it's not going to be 41,000 exactly. We're going to assert true. 41,000 is less than or equal to something like this. Dot get current time for testing. I don't know, something like that. All right. So a lot's to pretty much hate about this. This is clearly not the way we want to do this, but I just want to finish this test. Gives the beginnings of an idea, and then we gotta fix it. But so let's that's sort of the beginnings of a test. And so let's suggest this. Set current time for testing. So current time equals current time this dot, and do this, going to create one of those, and we're going to return current time here. And all right, so that's, we set it for testing, and now, well, what do we really want to do? We want the fire method to do something a little bit more interesting. So we override that. That's control space. We look for fire, and I don't think we're going to do super fire. We're going to do our own baby. So something like if well, current time is an int. Actually, it probably should be a long, shouldn't it? Yeah, it's definitely got to be a long. Long, and so he's going to say, you change the type of current time to long. Good, that's good. All right, and this guy had better be a long as well. And so if, well, why don't we say something really stupid like if current time not equals 0, then we're, you know, we've done something, and then else I don't know, maybe else current time equals system dot current time millis, something like that. So why don't we say something? Why don't we turn that into a method of its own? Say get time, get current time. All right, so we're going to get the current time, and maybe it's just this, that maybe it's just this. If it's equal to 0, we're going to override it with the system time, and then we're just going to say this. Well, I guess we'd better return something. Let's return current time. And so method return type to long. Good. All right. So what are we saying? We're saying that if we haven't set it, we're going to set it to the real system clock. Otherwise, we're going to just return whatever was set before. Now, so something like long time equals get current time, and so let's do exactly what I don't want to do, which is sleep here. Delay. And yeah, I guess so. Right, okay, so delay is in our abstract class. It's not currently visible, so we're going to say okay. so that's fine. Time discrete, time transition. Okay, and this guy needs to have a stack there. Okay, so thread sleep delay, blah blah blah. Yeah. Oh well, current time plus equals delay. Yeah, pretty hateful. Okay, let's see what happens. Boom. All right, we just wasted a second of our lives. Okay, but I think maybe the underlying message there is actually a good one, which is this is also a 12-year-old saying, do the simplest thing that can possibly work. And so whatever pops first into my mind, I'll do that, and I'll think about it. So what did we do here? We had a notion of a fake time, and so we set up our current time, our fake time for testing, and then we did the fire, but hadn't really, it's pretty clear that we need to do something significantly classier there than sleeping. But it's the simplest thing that could possibly work. The slightly even simpler thing that could possibly work is something like this. And this is, when we originally taught this is the sort of thing we were taught. Okay, you want 41,000? I'll give you 41,000. Here, let's have 41,000. And so, hard code answers until you figured out what you really want to do. So that's the sort of moral of the story. There is that we're not above anything to get the test to work the first time while we're thinking through actually how we really want to make it work. So obviously we got to figure out what we're going to do about that. Maybe that's something you can work on. But I think the point of this is to say, well, here's the beginning of something. Our time, by putting this method someplace else, we have the choice of overriding it or taking the current system time. And if we haven't overridden it, that's what we'll have. And if we have, and I don't actually know whether this logic belongs here or someplace else. Currently we have it here. Maybe it belongs in an animator. Kind of a problem to put it there, but some, things to think about. Anyway, so with the beginnings of an idea here, and clearly not right yet, makes our whole test suite a second longer, which I can't stand to do that for very long. But everything should run green. Let's verify that and then sync it. As long as it all runs green, we can sync it. Doesn't have to be done, just has to be green. That's the only rule. Other than that, we can't commit until it all runs green. And so far so good. Okay, all runs green. Let's sync it. All right, go back here. Where are we? Pipe core. Git status. Let's see what we got. Probably got a bunch of stuff. So we've made a bunch of changes. We changed abstract transition, discrete transition and transition, and we added some new files. So if we do git diff, we can see what we did. So we added the delay, and that makes sense. We put it as ints. We might want to consider that as longs, although it's a little bit scary. Maybe not. Maybe we don't do ints, or maybe we don't do longs. I'm reasonably confident that adding an int to a long is no problem. Having a delay that was actually bigger than an int is probably not the idea of what we want to do here. So maybe an int's okay. And then we added a getter and setter for that, and this is all in abstract transition, so that looks okay. And then, oh yeah, we changed discrete transition to not be final. And then what do? We created a couple methods in the transition interface, our set delay and get delay, and that's what's different. Now we've also got these two things we've added, and presumably we know what we've added, but that was our class and the test for our class, and we note that the class is in main and the test is in test. Always a good thing we keep that straight. So let's just do git add -a. Git status says it's all there. Git commit initial support for timed transition with hard-coded with bad hard-coded sleep. Hard-coded sleep. Alright, so create that. Let's do git push, and alright, that's up on timed transitions on my guy. So let's go look at him. Oops. I'm going to put we'll go take a look at him, and we got to pull it over to Sarah's. So GitHub, and I am signed in. Let me go to where are mine? Where's my repositories? Where are my repositories? Pipecore. And time transitions. I want to look at time transitions. Timed transitions. Okay. Bad hard-coded sleep. All right. So my branch is one commit ahead of Sarah Tanner's result. So I'm going to do. Let's do compare and pull request. Base fork. Blah blah blah. Able merge. Initial support. Okay, so that's pretty much it. My base fork is the time transition branch for Sarah's, and my time transition branch. I'm going to create this pull request and blah 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 blah. Base branch. So we've got this the Travis build, and I always like to wait for that. In this particular case, since there's actually nothing in her branch I just created that branch, but still, let's go there. Let's look at the details on the Travis build. It's chunking along, booting. Running on our legacy infrastructure. I've got to upgrade something. I'll worry about that later. Number 126. What's that mean? Well, this may take a little while. All right. Anyway, this is where we look. I think what I'll do is, oh hey, cool, it's starting, yay. Building, blah, 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 blah. Let's make sure that nothing craps out here. This is, of course, completely illegible, but processing. Well, this takes forever. Changes detected. Yeah. Well, still thinking about it. Okay, tests are running. That's always a good thing. Yay, build success. Cool. All right, loves us. All right, so now I go back here. All checks have passed. Merge pull request. Confirm the merge. Boom. All right. Now, just for laughs, let's if we look at this, if I look at pipe core, I look at commits. Oops, I don't want to look at that. I want to look at timed transitions. Time transitions has these guys. It has this this pull request here, as well as my original commit. Now, this is just being a little bit anal. If I go here and I say GitHub and I look at me, pipe core, and go to time transitions and I do commits, I see initial support for time transition 2.6 easy is my commit, and I go to Sarah's and I see initial support for time transition 2.6 easy. That commit's there, but there's an additional commit in Sarah's that isn't in my fork. Not only that, if I go back to my own machine and I do git log, my last commit is 2.6 easy, initial support for time transition. So my local repository and pipe core are at the exact same commit, but Sarah's is slightly different because it has the merge for the pull request. So I kind of like keeping everything pretty much exactly in sync. So here's how I can do that. On my machine, I can do Git Fetch Upstream. Upstream is Sarah. That's origin is what I was the fork I created from hers, and upstream is hers. So I fetch everything from upstream, and it pulls down at least one more commit, and then I got to make sure, first I verify I'm in the right branch, and I'm in time transition, so that's good. And then I want to say git merge upstream. I want to take upstream's version of things, timed transitions. And he does a fast forward. And then if I do git log, notice that my most current commit is now this pull request, 0baker5. And if I go look at Sarah's, 0baker5 is the most current commit. Now, my guy here is still, my fork is still back level one. So the last thing I do is I just do git push. Now you may or may not be committed. You may or may not have yours set up to default this way. To be specific, what we're really saying is git push origin, not upstream, but origin is your fork timed transitions. Mine is set to default to that, but that's the specific way to do it. Now that I pushed there, now I can refresh this, and now we see that my fork is at the 0 Baker 5.5 level. So what did we do? We made a commit locally, and then we pushed it to our fork. In my case it's sjday, in your case it would be Malta Shilling. And then we created a pull request, which we then processed. I think you'll be able to create one but not run it. And so I'll run it and integrate it. And then once it's integrated into Sarah's code, then to get everything back in sync again, we can just pull Sarah's code down, which is the fetch upstream, merge Sarah's code in, which should just fast forward straight across because it's just one extra commit. So we git merge upstream /time transitions, and then finally, so that puts Sarah's code and the local repository in sync. And finally, the closing loop is we push from the local repository up to our own fork, Malta Shilling or sjday fork, and now all three are in sync. So, all right, very long coda there, but that's where we are. So I'll talk to you tomorrow morning. See ya.